Hello friends, continuing with the chapter of nucleus, today we come to its sixth part, radioactivity. Now what is radioactivity? Let us try to understand. It is the phenomenon by virtue of which spontaneous decay of an unstable nucleus accompanied by emission of alpha, beta and gamma rays takes place without any stimulus from outside agency is known as radioactivity. I repeat, the phenomenon by virtue of which spontaneous decay of an unstable nucleus accompanied by emission of alpha, beta and gamma rays takes place without any stimulus from outside agency is known as radioactivity. For example, a radioactive nucleus XII, when emits an alpha particle, helium-4 it is converted into daughter nucleus Ya-4 Z-2 plus emission of alpha particles. Similarly, with example 2, radioactive nucleus XAZ, a parent nucleus, when emits an electron, that is negative beta particle, it is converted into a daughter nucleus with YaZ plus 1 with an electron and antineutrino emission. Now let us see third example. A radioactive nucleus XAZ, when emits a positron, that reduces to daughter nucleus YaZ-1 with emission of a positron and a neutrino. Now I look at this diagram. In this diagram we have shown electric field, and in the electric field we have placed a radioactive nucleus. Now if it emits alpha particles, then these are attracted by negative plates, and if it emits negative beta particles, these are attracted by positive plates. And if it emits positrons, then these are also attracted by negative plate. Then gamma rays, since gamma rays have no charge, so they come out straight. This is how we can imagine emission of alpha, beta and gamma rays. Now alpha decay or alpha emission. What is alpha decay? It is the process by virtue of which emission of fast moving helium nuclei takes place from nuclei having generally A more than 210 is known as alpha decay. I repeat, the process by virtue of which emission of fast moving helium nuclei takes place from nuclei having generally A more than 210 is known as alpha decay. For example, consider a radioactive nucleus XAZ. When it emits an alpha particle, it reduces to daughter nucleus Ya-4 Z-2. XAZ is parent nucleus and Ya-4 Z-2 is daughter nucleus. Now after emission of alpha particles, parent nucleus is transformed into daughter nucleus with atomic mass smaller by 4 and atomic number smaller by 2. I repeat, after emission of alpha particles, parent nucleus is transformed into daughter nucleus with atomic mass smaller by 4 and atomic number smaller by 2. Remember this decay equation because we are going to state it again in displacement laws. Now kinetic energy of emitted alpha particles. Consider the example XAZ is a radioactive nucleus which emits an alpha particles and reduces to daughter nucleus Ya-4 Z-2 with emission of alpha particles. Now both Daughter nucleus and alpha particle fly apart in opposite directions due to action and reaction. When alpha particle emits out in forward direction, then the daughter nucleus moves in opposite direction. Now alpha particles so emitted has fixed kinetic energy given by the expression half mv square is equal to a minus 4 divided by a into q, where q is the disintegration energy given by the expression q is equal to mx minus within bracket my plus m alpha bracket closed, then large bracket into c square, where mx minus m y plus m alpha is mass defect. This energy is transferred to daughter nucleus and alpha particles and both fly apart. Now proof of kinetic energy, which is equal to half mv square equal to a minus 4 divided by a into q. Now let us derive this expression. Now consider alpha decay in the following example. XII is a parent nucleus. When it emits an alpha particle, then it reduces to daughter nucleus y a minus 4 z minus 2. Let mx be the mass of parent nucleus at rest, my be the mass of daughter nucleus, and m alpha be the mass of alpha particles emitted. Then disintegration energy q is equal to large bracket begins mx minus small bracket begins my plus m alpha small bracket closed large bracket closed and into c square. I repeat, disintegration energy q is equal to mx minus my plus m alpha into c square. Let us mark it as equation 1. Now let us make use of law of conservation of momentum. Consider alpha decay in the following example, where XIZ is parent nucleus, alpha particle is emitted, and after emission it reduces to daughter nucleus y a minus 4 z minus 2. So consider this decay. Now since daughter nucleus and alpha particles both fly apart, therefore possess their respective velocities in opposite direction. Therefore, let Vy be the velocity of daughter nucleus and V alpha be the velocity of alpha particles. Then according to law of conservation of momentum, my Vy plus m alpha into minus V alpha is equal to 0. Y minus V alpha, because Vy and V alpha are opposite to each other. So one Vy we have taken as positive, then V alpha must be taken as negative. Or my Vy minus m alpha V alpha is equal to 0. Let us mark it as equation 2. Now according to law of conservation of energy, half my Vy square plus half m alpha V alpha square is equal to q, because q being disintegration energy. Let us mark it as equation 3. Now from equation 2 we have Vy is equal to m alpha V alpha by my, and substituting in equation 3 we have half my within bracket m alpha V alpha by my square plus half m alpha V alpha square is equal to q, or half m alpha V alpha square within bracket m alpha by my plus 1 is equal to q, or half m alpha v alpha square is equal to q divided by 1 plus m alpha by my, or it is equal to my divided by my plus m alpha into q, or it is equal to a minus 4 divided by a minus 4 plus 4 into q, or it is equal to a minus 4 by a into q, or half m alpha v alpha square is equal to a minus 4 divided by a into q, and is the kinetic energy with which an alpha particle is emitted. Okay. So this is the expression for kinetic energy of alpha particle which is emitted on account of radioactivity. Now assignment 13 continued. Question number 16. The nucleus of an atom initially at rest decays by emitting an alpha particle as per the equation Y23592 decays to X23190 plus helium-42 plus energy. It is given that the binding energy per nucleon of the parent and the daughter nucleus are 7.8 billion electron volt and 7.835 million electron volt respectively, and of alpha particle is 7.07 million electron volt. Assuming the daughter nucleus to be formed in the unexcited state and neglecting its share in the energy of the reaction, calculate speed of emitted alpha particles. Take mass of alpha particle to be 6.64 into 10 raised to power minus 27 kgs. I repeat, take mass of alpha particle to be 6.64 into 10 raised to power minus 27 kgs. Okay. Now beta decay. The process by which emission of an electron or a positron takes place from a nucleus and nucleus attains greater stability after emission is known as beta decay. I repeat, the process by which emission of an electron or a positron takes place from a nucleus and nucleus attains greater stability after emission is known as beta decay. For example, a radioactive nucleus XII, when emits a beta particle, that is electron, it reduces to a daughter nucleus YaZ plus 1 plus an electron plus an antineutrino. This is electron emission. Here the mass number of daughter nucleus remains same and the atomic number increases by 1 if electron is emitted. Now for example 2, potassium 4019, when emits an electron it reduces to calcium 4020, stable calcium. Here mass number 40 remains 40 but atomic number becomes from 19 to 20, that is increases by 1. Actually what happens inside nucleus is a neutron decays into a proton, an electron and an antineutrino. I repeat, what happens actually in nucleus, a neutron decays into a proton, an electron and an antineutrino as shown in the equation, and 1 0 when decays it becomes proton 1 1 plus an electron plus antineutrino. This is what happens actually inside the nucleus and we say it is beta decay. that is electron decay, beta negative decay. Okay. Now beta decay continued. Example 3, when a positron is emitted from X say Z, then it reduces to Y4 Z minus 1 plus a positron plus a neutrino. This is positron emission. Here the atomic number reduces by 1 if positron is emitted, mass remains the same. The positron is an antiparticle of electron with mass equal to 9 into 10 raised to power minus 31 kg and charge 1.6 into 10 raised to power minus 19 coulomb. Positive. So it has a positive charge of 1.6 into 10 raised to power minus 19 coulomb, whereas electron has a negative charge of 1.6 into 10 raised to power minus 19 coulomb. It is being antiparticle of electron. Now example 4. When sodium 2211 emits a positron, it reduces to neon 2210, stable neon. Now here mass remains same, 22 with sodium, 22 with neon. But atomic number reduces by 1 from 11 to 10. Now actually what happens inside nucleus? A proton decays into a neutron, a positron and a neutrino. So this is what happens inside nucleus when a positron emits out through a radioactive nucleus. That is P11 reduces to N10 plus a positron plus a neutrino. Okay. Experiment 13 continued. Question number 17. A radioactive nucleus decays by emitting a beta particle. How will the proton and neutron ratio of the daughter nucleus change as compared to parent nucleus? So you solve this question, once for beta plus and once for beta minus. That is once for electron emission, once for positron emission. Now we come to orbital electron capture. What is orbital electron capture? Let us try to understand. When an electron falls into the nucleus, anyhow it interacts with proton and the proton is converted into a neutron. I repeat, when an electron falls into the nucleus, anyhow it interacts with proton and the proton is converted into a neutron. That is how neutron stars are formed due to backkick of supernova. And you know in supernova what happens? Due to the backkick, the core is compressed to tremendous densities and electrons are suppressed to nucleus where they interact with protons and convert themselves into a neutron. So neutron stars are formed. This is how the theory behind formation of neutron stars. So what happens? Proton 1 plus an electron, it gives you a neutron N10. So in this Z becomes Z minus 1. Okay. Now gamma decay. What is gamma decay? Let us try to understand. The process by virtue of which a radioactive nucleus after emission of an alpha or a beta particle leave daughter nucleus in excited state, which in order to acquire a stable state in single or successive transitions emit photons of energy. These photons of energy are nothing but gamma rays. I repeat, the process by virtue of which a radioactive nucleus after emission of an alpha or a beta particle leave daughter nucleus in excited state, which in order to acquire a stable state in single or successive transitions emit photons of energy. These photons of energy are nothing but gamma rays. Now, for example, let us take cobalt 6027. When it emits an electron, it reduces to nickel 6028, and this nickel 6028 is in excited state. Now it will acquire stable state. And how it acquires stable state? It first emits a photon of energy 1.7 million electron volt. Again, after this emission, nickel 6028 remains in unstable state, and in successive transition it emits a photon of energy 1.33 million electron volt and reaches stable state. Two photons of energy of 1.7 million electron volt and then 1.33 million electron volt are nothing but the gamma rays. Now, energy level diagram of this emission, that is gamma emission. Now, here is cobalt 6027. When it emits an electron, it reduces to nickel 6028 here. Then it emits a photon of energy 1.7 million electron volts. Nickel still remains in unstable state. Again it emits a photon of energy 1.33 million electron volt and reaches stable state. Now these two photons of energy 1.7 million electron volts and 1.33 million electron volts are nothing but gamma rays, and nickel 6028 reaches stable state. This is how gamma emission takes place. Now, assignment 13 continued. Question number 18. A nucleus makes a transition from one permitted energy level to another level of lower energy. Name the region of electromagnetic spectrum to which emitted photons belong. What is the order of this energy in electron volts? I repeat, a nucleus makes a transition from one permitted energy level to another level of lower energy. Name the region of electromagnetic spectrum to which emitted photons belong. What is the order of this energy in electron volts? Okay. You answer this question on the basis of the text that you have learned. And now we come to properties of alpha, beta and gamma rays. Now, properties of alpha, beta and gamma rays. In this column we show the points which is to be compared. This column shows properties of alpha rays, this column shows properties of beta rays, and this column shows properties of gamma rays. Now, point by point we discuss. First we take up definition of each. First, definition of alpha rays. Alpha rays are stream of fast moving helium nuclei He++, emitted from nuclei generally having A more than 210. For example, XII, when emits an alpha particle, it becomes Ya-4 Z-2. Now, beta rays. The definition of beta rays. The beta rays are stream of electrons or positrons emitted from a nucleus, and nucleus attains greater stability after decay. For example, XIZ, when emits an electron, it becomes Ya+1 with emission of an antineutrino, and when it emits a positron, then XAZ after emission of a positron becomes Ya+Z+1 plus a neutrino. And what are gamma rays? Gamma rays are electromagnetic waves having energy equal to h nu and wavelength shorter than X-rays. So this is how we define the three rays. Now we talk of charge associated with three rays. The charge on each alpha particle is twice E, where E is equal to 1.6 into 10 raised to power minus 19 coulomb, positive. And charge associated with beta rays is again equal to E, and E is equal to plus minus 1.6 into 10 raised to power minus 19 coulomb. Charge on negative beta rays, that is electrons, is minus 1.6 into 10 raised to power minus 19 coulomb, and charge on beta plus, that is positron, is plus 1.6 into 10 raised to power minus 19 coulomb. Now gamma rays possess no charge, being electromagnetic waves. Now third point, deflection by electric and magnetic field. Alpha rays are deflected by electric and magnetic field. Beta rays are also deflected by electric and magnetic field, being associated with charge. And gamma rays are not deflected by electric and magnetic field, being electromagnetic waves. Now fourth point, effect on photographic plate. All the three affect photographic plate. Alpha rays affect photographic plate and cause fluorescence. Beta rays also affect photographic plate and cause fluorescence. Gamma rays also affect photographic plate and cause fluorescence. Now fifth point, ionization. Alpha rays produce strong ionization having larger mass. Beta rays possess less ionizing power as compared to alpha rays, being lesser in mass, and electromagnetic waves, that is gamma rays, possess little or no ionizing power, having no mass, etc. Now sixth point, penetrating power. Alpha rays possess small penetrating power. Paper or aluminium foil even can stop it. Beta rays possess large penetrating power as compared to alpha rays, being smaller in size. Now gamma rays possess large penetrating power, can pass through many centimeters of lead even. Now seventh, kinetic energy. Alpha rays possess small velocity, and kinetic energy is given by A minus 4 divided by A into Q, where Q is disintegration energy and A is mass number. Beta rays move with greater velocity, that is 1/10 of velocity of light, that is 1 by 10 into C. It is 1/10 of velocity of light. So beta rays move with this velocity, and gamma rays move with velocity of light, that is 3 into 10 raised to the power 8 meter per second. So these are 7 points where we compare the properties point by point, and it is easier to learn this way. I feel you may be having your own method of learning things, but this is the chart which is going to help you to compare the properties of three rays. Thank you so much. Next time we'll continue with this topic, radioactivity, and we'll take up laws of radioactivity. Till then, goodbye and good luck to you.